Hello everyone, my name is Himashini. Let me describe a little bit about the problem we chose and my contribution to this project. Here we have to apply machine learning algorithms on a real world data set. So student stress have become a major problem these days. So we have choose the student stress as our real world problem and use this data set uh, as our data set. So this data has been collected using a survey which has uh, several categories of data, and it has 1100 data rows with 21 columns, and it has a target variable which is the stress level. So as my contribution to the project, I have done the logistic regression model part. So here, this is the code. And first of all, I have imported the essential Python libraries like pandas, numpy, and I have let's use scikit-learning here for data handling, analysis, and model building. Here I have loaded the data set and printing the information of the data set here, and data preprocessing is done here. In data preprocessing, it is a crucial step actually. So I've checked any missing values and replaced them with the median value of each numerical column to ensure that there's no gap in the data. Here I have also examined the target distribution, and then after that I have separated the data set into features and target variable and split it into training set and testing set using 80 to 20 ratio. After that, I have standardized the feature data using standard scalar to make sure all features are on the same scale, which helps the logistic regression model to perform better. Uh, After that, I have trained the logistic regression model here using multinomial setting. And here is the model evaluation part, which is done using several performance metrics like accuracy, precision, recall, likewise. And here, classification model, and use the confusion matrix. And finally, feature importance. So overall, this code demonstrates the complete machine learning workflow from data loading and pre-processing, model training, evaluation, and interpretation using logistic regression to predict student stress level effectively.
Hi everyone, my name is Nushra. In this video, I'll be talking about my part of our project, the Random Forest Classifier. The project is based on the student stress monitoring dataset from Kaggle. Our main goal is to predict the level of stress among students, whether they are experiencing no stress, ill stress, or distress, based on a range of factors like mental health, environment, or academics. The dataset contains 1,100 records each with 20 input features and one target variable called stress level. Some of the important features include insight level, self-esteem, sleep quality, academic performance, and blood pressure. There were no missing values, and since all features were numeric, minimal preprocessing was required. I split the dataset into 80% training and 20% testing, keeping the class distribution balanced among the three stress categories. Now let's look at the random forest classifier. Random forest is an ensemble learning method, meaning it builds many decision trees and combines their predictions to get a more accurate results. Each tree learns from a different random subset of the data, which help the model avoid overfitting and improves generalization. In my code, I use scikit-learn's random forest classifier. setting the number of trees to 200 and setting the class weight to balance to handle any imbalances. After training the model on the training data, I used it to predict the stress level for the test set. To evaluate the model, I used several performance metrics such as accuracy, precision recall, and F1 score. Random forest achieved an accuracy of 89%, while precision recall and F1 scores also close to 0.89. When looking at the confusion metrics, we can see that model correctly predicted most samples for all three less levels, which means it performs consistently and doesn't favor one class over another. One of the greatest advantages of random forest is that it can show which features are most important for predictions. According to the model, the most significant factors influencing student stress were blood pressure, sleep quality, and academic performance. This provides valuable insight. It suggests that both physical health and social or academic environments play a major role in determining stress level among students. Random forest is better at capturing nonlinear relationship and interaction between multiple features. In conclusion, the random forest classifier provided a highly accurate, well-balanced prediction of stress level, and it also helped identify the key factors contributing to stress among students. Thank you.